So number 1 says at 298 Kelvin and 1 atm, Br2 is a liquid and Cl2 is a gas. These observations provide evidence that under the given conditions, and then we have to pick the correct option. So again, when you're looking at states of matter, you're comparing two substances that are different states of matter, you're comparing the intermolecular forces. Remember that solids have the strongest intermolecular forces and gases have the weakest. So if Br2 is a liquid and Cl2 is a gas, that means that Br2 has stronger intermolecular forces than Cl2 does. So what we need to do is we need to pick the option that goes along with the idea that Br2 would have stronger intermolecular forces than Cl2. So if we read through, A says forces among Br2 molecules are stronger than those among Cl2. Well, that's correct. All right, A is the correct answer for number 1. Now, I'll talk about why the other ones are not correct. And it's because B, C, and D all talk about bond strength. Bond strength only matters if you are looking at a chemical reaction. If you are looking at breaking the bonds of Br2 or Cl2 and forming something completely new. So if we were looking at the overall enthalpy of a reaction, delta H, and we look at bonds broken and bonds formed, that's when we would look at the strength of a bond. But when we're just looking at phase changes or intermolecular forces, the strength of the bond does not matter. So number 1 is A. Number 2, in which of the following liquids do the intermolecular forces include dipole-dipole forces? So remember, dipole-dipole forces will only be exhibited in a polar molecule. Well, if you take a look at all of your options, any of them that are nonpolar, you can cancel out, or you can eliminate those. F2, that's nonpolar. It's perfectly symmetric, it's nonpolar. F2 is nonpolar. CH4 is nonpolar, perfectly symmetric. CF4 is nonpolar, it's perfectly symmetric. That only leaves us with CH2F2. And so for number 2, our only option is D. So 1 is A, 2 is D. Before we get into what we're going to work on today, I do want you to turn in your Do Now sheets via Google Classroom like you did last time, just because we have so many people that are, switching back and forth between being here or being at home. So it's just going to be easier to have everyone turn in their Do Nows in the same place. So you'll notice down in the corner, I just want you to take pictures of both sides of your Do Now sheet. In Google Classroom, there's an assignment that I pushed out this morning that says Do Now 12/11/20. You can take a picture, you can scan it as a PDF, either one, doesn't matter to me, because I'm just gonna look and make sure that you have it done. I don't need to write on it with my iPad, so if it's not a PDF, it's okay. But either take pictures or a PDF, but make sure you have both sides attached to the assignment class. So if you want to take just a couple minutes and take pictures, attach it in Google Classroom, you could do that. It has a due date of 2:30 today, but just make sure that if you have time, just do it right now. So those of you that are at home, you can do the same thing. Take pictures of both sides of your Do Now sheet, whether you're using the Do Now sheet from class or a separate piece of paper. Take a picture of both sides and upload it to the assignment in Google Classroom. And while you're continuing that, you're getting your Do Now sheet uploaded, I'll just talk about what we're going to be doing today. So in class today, we're going to start by finishing the Unit 4 free response questions. So that was questions 7 and 8. So you'll be working in small groups just like yesterday. We'll time it, we'll go over the right answers, and then we're going to play a review Kahoot. First period, we just got the questions done. If we don't get to all of the questions, this Kahoot, the link is posted on the class website. So you can go to the class website, and if you click on that link, you can click through the questions and review as you need to. Obviously, this isn't going to cover every single topic that we've looked at, but it's going to give you a really good idea of chapter 11, 12, and 13. And then you can use the weekends to work on the Unit 4 review packet. So again, if you did not pick up the unit packet yet, it's on the side counter still, or it's on the class website. but use the weekend to work on the Unit 4 review, get ready for the test. So those of you on Google Meet that are gold group, you will be taking it Monday. You guys in class, so Tuesday is going to be the green, and if you are completely online, you'll be taking the test Tuesday as well. So like always, so you guys are taking the test on Tuesday. You do not have it on the Google Meet on Monday. So you can use Monday to review. If you have questions, you can send me questions via email or via Remind. During class, I can answer your questions, but you do not have to get on the Google Meet. And then Tuesday, those of you that are taking the test Monday, you don't have to get on the Google Meet. And then anything else, I'll have you pick up next week as well. So what we're going to do is we're going to go ahead and we're going to start free response questions. So I'm going to have you guys working in small groups. So you can grab a calculator, periodic table, equation sheet, and then the free response packet from yesterday. And so when we start the free response questions, we're going to start with number 7, which is on page 6. All right, so again, we're going to start. So you guys that are at home, I will be putting you into breakout rooms. We're going to be starting with number 7 on page 6. So for number 7, this is considered a short question. This is only going to take 5 minutes. So you can move around, right? If you haven't moved around yet, you can, move chairs, push desks together for now. And this is just going to be 5 minutes. So what I'm going to do is I'm going to set a timer for 5 minutes. And then at the end of 5 minutes, we'll go ahead and go over the correct answers to this. Again, equation sheet, periodic table, calculator, you can use all of those. All right, so you guys in the breakout rooms, I'll see you back in 5 minutes. So some questions might take you more time, less time. This, I kind of did a little less than like the 7 to 9 minutes, but it just kind of gives you an idea as to, how much time questions can take. So what we're going to do is we're going to look at the responses for these questions. So for number 7, most of this was based on intermolecular forces. And so this is going to be a way for us to be able to review the IMFs and proper ways of justifying and explaining different types of intermolecular forces. So they give us these 2 Lewis structures. And then part A says, which compound has the higher boiling point? Justify your answer. The types of intermolecular forces in both substances should be included. When you see it say something like that, that should be the first thing that you say. So when it says to be sure to include the types of intermolecular forces or types and strengths, make sure that's like the first thing that you say in your response. So when you're looking at the Lewis structure for CH4 and CCl4, and you're given those at the top of the page, both CH4 and CCl4 are nonpolar. They are both symmetric molecules. So since they're both nonpolar, they will only exhibit London dispersion forces. Now, whether you call them London dispersion forces or London forces or dispersion forces, it's all the same thing. So you want to start by saying both molecules are nonpolar, so they only exhibit London dispersion forces. Then we need to make sure to answer the question, which compound has the higher boiling point? So remember, the higher boiling point is the one that's going to have the stronger intermolecular forces, because higher boiling point means more energy needs to go in to overcome the intermolecular forces. So since both compounds exhibit London dispersion forces, the strength is based on the number of total electrons. The strength of dispersion forces is based on the number of total electrons because it's based on the polarizability of the electron cloud. Nonpolar substances are not based on polar bonds because it's a nonpolar molecule, so it doesn't matter. But it's based on electrons. So since CCl4 has more electrons, the electron cloud is more polarizable. This is a really important explanation, right? More polarizable, increasing the strength of the dispersion forces. So CCl4 has the higher boiling point. Right? So again, dispersion forces is based on the number of total electrons because that results in a more polarizable electron cloud. So CCl4 is going to have the higher boiling point. So you can notice that 1 point was earned for saying that CCl4 has the highest boiling point, and then 1 point was for the justification. And you had to say that they both had dispersion forces. So notice here it says if the response indicates that either of them have any other type of IMF, you didn't get that second point. So then part B, at 400 Kelvin, both compounds are gases. At this temperature, which compound behaves more like an ideal gas? Justify your answer, including reasoning about both molecules. So remember we talked about when a gas behaves ideally and when it behaves more as a real gas. And we talked about specific conditions like temperature and pressure. But these two gases are at the same set of conditions. And so what we're looking at is the interactions between the molecules. Real gases have attraction. Ideal gases have no attraction between the molecules or very weak attraction. And so CH4 will actually behave more like an ideal gas because an ideal gas is one that has no attraction between the molecules. So since CCl4 has greater or stronger intermolecular forces, those molecules are more attracted to each other. It will behave more like the real gas. CH4 has weaker intermolecular forces, so they're not as attracted to each other. That will behave more as an ideal gas. So remember when we talked about real versus ideal gases, we were talking about intermolecular forces and the attraction between the gas molecules, and I kept saying we haven't covered IMFs yet, that's next. Well, now we've covered intermolecular forces, so now we can actually see why some gases behave ideally and while others behave as real gases. And it's based on those intermolecular forces. And then finally, part C. So this is a particle diagram question. So it says that CCl4 liquid is placed in a container and some of the CCl4 evaporates. So it wants us to draw a particle diagram to show the species in the container after some has evaporated. So not all of it, but after some of the CCl4 has evaporated. And so if we look at the particle diagram, here's how they would have scored this question. So it says the drawing should show the following. Now it doesn't tell you how many CCl4 molecules to draw. So the number that you pick really is up to you. They showed 7, you could have showed 8, could have showed 10, you could have showed 5. But what you need to do is you need to make sure that you're showing both states of matter because it said only some of the CCl4 had evaporated. So you need to show some CCl4 molecules close to each other near the bottom of the container. That's the liquid. Then you show some 1, 2, 3 CCl4 molecules spaced out toward the top of the container. That's the gas. But notice it's all still CCl4. It's a phase change. We are not breaking the covalent bonds inside CCl4 molecules. We're not breaking apart CCl4 to form carbon and chlorine. It's simply undergoing a phase change. It's still CCl4. We're just overcoming some intermolecular forces. So that was part C. Any questions on number 7? Okay, so if not, we're going to go ahead and go to number 8. So number 8 starts on page 7. And with number 8, I'm going to give you guys 8 minutes. So those of you that are going to be in breakout rooms, you'll have 8 minutes, and then it will bring you back at the end of the 8 minutes. You guys in class will have 8 minutes. I'll put a timer up on the board. So again, number 8, you have 8 minutes. Once we have everybody back, we'll go through the answers to number 8. Now with number 8, you could see that this was pulling in Lewis structures and shapes and bond lengths. So free response questions that we will see really more second semester, we will have topics that we're covering at that point. But we're also going to see more and more old topics coming back into free response questions, because when it comes time for the AP test, so their plan is still to have an in-person test in May. So all the AP tests will still be like they were 2 years ago, which means we have multiple choice and we have free response. The free response questions are not just IMFs or not just periodic trends, not just electron configurations. Everything will be more kind of intertwined within the questions. And so we'll start to see more and more questions like that. And this gives you an idea as to what that might look like. So for number 8, use the information in the table to answer the question. So part A wanted us to draw the complete Lewis structure for ethine and put it into the appropriate spot. So ethine is C2H2. You could have drawn it either using the dots or using the lines, but either way, you have a single bond between the H and the C's, and you have a triple bond between the 2 carbons. And so that was awarded 1 point. For part B, which of the 4 molecules contains the shortest carbon-to-carbon bond? And explain. So the shortest bond is the triple bond, because you have 6 electrons shared between 2 atoms rather than just 2 in a single bond. So ethine contains a triple bond, so it's the shortest length. All of the other molecules have single bonds. Triple bonds are shorter. So that was 2 points. 1 point for saying ethine, 1 point for giving the correct explanation. Part C, a Lewis structure was given for ethanoic acid. 2 of the carbons were labeled CX and CY. Wants us to identify the geometry of the arrangement of atoms. So that one's the molecular geometry. Part 1 of carbon X. So carbon X has 3 atoms bonded, 0 lone pairs. So carbon X is trigonal planar. Carbon Y, 4 atoms bonded, 0 lone pairs. That's tetrahedral. So carbon X was trigonal planar. Carbon Y was tetrahedral. The geometry of the arrangement of atoms, again, is the molecular geometry. Part D, so now we're getting into the intermolecular forces. Part D says energy is required to boil ethanol. Consider the statement. As ethanol boils, energy goes into breaking a CC, CH, CO, and OH bonds. Is this statement true or false? Justify your answer. So this is now the 2nd or 3rd time you've seen something like this in a free response question. So you should say the statement is false. Boiling is a phase change. Phase changes overcome intermolecular forces. All of the bonds given in the statement are covalent bonds. Covalent bonds are not broken during a boiling process. So the statement is false. All of the bonds described are intramolecular, right? Or you could say they're covalent bonds. These bonds are not broken during boiling. They're not broken during phase changes. When ethanol boils, we're overcoming intermolecular forces, not intra. And then part E, identify a compound from the table that is nonpolar and justify your answer. So you could have picked one of 2 different molecules. You could have said ethane or ethine. Either one of those would have been a good answer. And the reason needs to either be 1, that all of the bond dipoles cancel, or 2, the molecule is symmetric. Most people probably would have said that it's symmetric. But notice that it says the explanation must refer to the shape of the molecule. So saying something like all hydrocarbons are nonpolar, or it consists only of C's and H's, that wouldn't give you the point. Instead, you have to say all of the bond dipoles will cancel, or there's no there's no net dipole, that would be okay, or talk about it being symmetric. But one of those explanations is what you needed. And then finally, part F, ethanol is completely soluble in water, whereas ethane thiol has limited solubility. Ethanol, the OL means you have an OH group. Ethane thiol means you have a sulfur hydrogen group. So if ethanol is completely soluble in water, that means it interacts with water very well. If ethane thiol has limited solubility, that means it doesn't interact very well. So it says account for the difference between the two compounds in terms of intermolecular forces. So ethanol is able to form strong hydrogen bonds with water. Ethane thiol is not. And so since ethanol can form those strong hydrogen bonds, it's more likely to be soluble than ethane thiol. So notice here it says, note, the answer must clearly focus on the solute-solvent interaction. Just the mention of hydrogen bonding does not earn the point. So you have to talk about how ethanol can hydrogen bond with water. And that creates those strong forces. Okay, so that shows us how this question would have been scored. So now we've gone through different types of questions with chapters 11, 12, and 13. You can see how we look at intermolecular forces in different ways as well. Any questions on these before we shift over to the review Kahoot? All right, so we're going to switch over to the review Kahoot.